So in this case, we are going to consider our module 7, which is working on the second moment of area and also the second moment of mass, which is also referred as the moment of inertia. So actually, we have had these questions from the question papers as we have been answering those full question papers. So we want to consider this into detail so that we can understand each other, as I promised on those question papers revisions, that we need to talk about this. We need to consider this part. If you are to consider on your question papers as you are working with this module, we are going to have actually questions on question number 5. That is where we are going to be having these questions. Remember, question number 5 contains that part of the definite integrals. From the definite integrals, the areas and the volumes, we also have that part of the second moment of area and the second moment of mass on that same question number 5. So we want to see how to answer these typical questions that will be on this nature. All right, so without wasting much of our time, in our case, we've got two things that we consider here, the second moment of area and that of the mass. So we are going to start focusing on the second moment of area. What is it actually that we consider when we have moment from our engineering science? We've also been talking about this moment of force, moment of this. You saw that when you are considering the moment of a force, it was going to be the force times the perpendicular distance, the distance from the reference axis from our engineering science. So the moment concept is simply the product that we have of a physical quantity. When you talk about a force, it was force times what? The distance, perpendicular distance. So it's all about that. The product of a physical quantity. The product of a physical quantity. All right, so we're going to have this, the product of a physical quantity, all right, and a perpendicular distance, all right, and a perpendicular distance from the reference axis, from the reference axis. So you'll be given the axis, which is referred to as the reference axis, all right? That is what we have, moment, the moment of force, the moment of what? So if we say the moment of area, just to say moment of area, meaning to say there's supposed to be what is multiplied moment of what? Quantity, area. So it is supposed to be area times what? The perpendicular distance. So this is the part of the perpendicular distance. Just to say moment of, I'm just here to say moment of what? Product of that physical quantity to the perpendicular distance. So if we say the second now, the issue will be on the perpendicular distance. It will be squared. Once we say the second moment of area, the distance will be squared. So a second moment is when the perpendicular distance is being squared. So let's just consider to say, when you say a second moment, just to say a second moment, it means that is going to be what? The product of a physical quantity that we had before, a physical quantity. All right. And so this time is going to be the square and the square. Take note, the square. Once you say second, it will be the square. of what? The perpendicular distance. That is the case. The square of the perpendicular distance from the reference axis. So if we understand these guys, these terms, it is going to be actually easier for us to attempt these questions which will follow. All right, so that is the condition. The square now. You must have the square of the perpendicular distance. This is what I was explaining. So if we say the second moment area of, what are you considering of? That's your quantity. So in our case, we're just going to consider our area as our quantity. So it's of what? Area. So it's area times that perpendicular distance here squared. If it is second moment of area. So the perpendicular distance there, I'm not talking about that because it is referred from where? From the reference axis. So if it is maybe from the x-axis, okay, the issue of the reference axis, guys, let's talk about this before we consider anything else. When we say the reference axis is just like this, the issue of the reference axis, another part that will affect us in our calculations. If you don't understand this, is going to be actually something else. All right. So the issue of the reference axis is the one that you are working with, the axis that you are referring from, the axis you are referring from, the axis you are referring from. Which axis are you referring from? From the x-axis with respect to the x-axis. That is with respect to what? With respect to what? So with respect to what? So if we say, in our case, we're talking about the second moment of area, which is actually referred by the letter I. This one, all right, sorry. It's another part. Let me just indicate here. Then we'll talk about that here. So the symbol that we are going to use is the letter I, like this. This I for what? For the second moment of area. So it is going to differ with this part. Is it from the x-axis or from what? From the y-axis. We're going to talk about that in those examples that follow. So that is the issue of the reference axis. Now, if we say our second moment of area is taken with respect to the x-axis, with respect to the x-axis, it means this is our second area moment with respect to the x-axis, referring from what? The x-axis. The axis that we are referring from with respect to what? X-axis. So it affects this part to say, let's say we are given something like this. I want you to say this is your x-axis and this is your y-axis. You'll be having a certain object or a certain shape that you'll be having. In our case, we'll be working with a rectangle and a circle, those secular, the secular lamina or a rectangular lamina. So given a certain object, if we say from, like from the x-axis, it means we will be referring to a distance going up from the x-axis, from the x-axis. That is what it means. The perpendicular distance is this one. From the x-axis, we are going up. That is the distance from the x-axis. From where are we moving from? That is the major part here, going up. All right. So it means we are talking of a vertical distance whenever we say from the x-axis. We'll be talking of what? The vertical distance. Vertically, we'll be talking of what? The y values. So it means the distance that you'll be talking about there is for the y. That is the consideration. The distance is for the y. This is our perpendicular distance from the x-axis. This will be our perpendicular distance. All right. So we have got our perpendicular distance. So it follows that, guys. I want you to take note about this issue of our second moment of area. If you understand this, you're done. Whenever you see that you are using the perpendicular distance, let's say this one, it's for the y, meaning to say for the y values, it means the representative strip that you are going to use for that particular shape. Let's say we are referring to a rectangle. In this case, maybe something like this. All right, that you'll be having. The representative strip, now you understand this of the representative strip from our areas and volumes. The strip, I said, whenever you talk of the representative strip, it is for the y, it is for the x. It means it affects the limits. The strip for y, the limits for y as it is. The strip for x, the limits for x. So, but in our case here, I want us to understand the issue of the strip to the perpendicular distance. The perpendicular distance, if it is y like this, it means automatically, guys, the strip that you're going to use is for y. You're going to be using the strip for y. This will be your condition. You'll be using this representative strip for y. So this is what it must be like. The perpendicular distance is for y. The strip also is for what? For y. This is our case. These two are supposed to be the same. They are supposed to be the same. Remember, we need their product at the end there. All right. Sorry, I want this part. Remember, I was talking of the product. The product of a physical quantity to the square of the perpendicular distance. So in our case, our physical quantity, we're going to refer to area. So we're going to talk of what? Area times the square of this perpendicular distance. That is our case. That is our case. So if with respect to x, all right, we are talking about this. I want us to understand this is our definition, guys, here. We are saying, guys, second moment product of a physical quantity and the square. In our case, we are saying it is the second moment of what? Of area. Of area. Second moment of area. Second moment of area. So we want to understand this issue of the where the reference and this but that we're talking about. So it is supposed to be of the quantity of area. Is it of mass? We're talking of area this time. So it is area times the perpendicular distance squared. So this one, it is supposed to be the perpendicular distance squared. The square of it. Here, the square. Physical quantity and the square. That is what we have. And that perpendicular distance is the one that is taken from where? From the reference axis. That is why here I was talking about the issue of the reference axis here. To say, if let's say that our reference axis is the x-axis, we are taking just an example like this one. Our reference axis is the x-axis. So it means our perpendicular, it was supposed to be like this here. The moment of inertia was going to be what? The product, we're going to have the area presentation, then the product, which is this one, y squared. So in our case here, we're going to use y squared. So if it is like this one, it will be just like x. With respect to what? With respect to from the x-axis, with respect to x. So it was going to be like this. Where we are going to, so we're supposed to have the product of the area and the product of this distance, which is our distance as we can see, from the x-axis, our distance is what? Is y. From the x-axis, it's y. So it will be y squared. So as you can see, if this is x, this is supposed to be y. From x. That is our condition. So if we are dealing with a rectangle, we're going to talk about this later on, these formulas, do not worry. So if you're working with a rectangle, you know, the issue of the rectangle, the length times the breadth. That one also is going to affect when you are calculating both. We're going to talk of how to calculate the area. So on the area now, we'll be talking of the area of the strip. The area of the strip. There is what we call the area of the strip. So the area of the strip, guys, is when we say this is the representative strip that we have here, guys, is for what? This is for y. As we can see, it covers a certain distance here. I want us to see here. Let us just finish with what? With our x-axis. From x-axis, we have the area of the what? Of the strip. So the area of the strip, depending with the shape, as we are working with a rectangle in our case, I want us to use one format. So in our case, we are going to notice that there are other questions which can be calculated differently, but giving us same answers. So for us to have a uniform consideration from now going onwards, because we want to have the same thing. Yes, for other question papers that we have done, we have been mixing depending with the method that I just want to use, or depending with the way that I want to calculate on that certain question. But as for of now, we want to work with a similar presentation. So as of our rectangle, whenever we've got a rectangular presentation, let's consider our rectangle like this. Let's consider our rectangle like this, whereby the longer side is this one, and this is our shorter side, all right? We can have our rectangle like this, guys. It's up to you the way that you present it, where this is your longer side, your shorter side, all right? So in our case, let us have it this way so that we'll be having something that is uniform as we'll be having our revisions. So the shorter side is the one that is going to be our B, which is our breadth. All right, so we're going to call this one our breadth. And the longer side is going to be our length. But in our presentation, we're going to call it the height. As we can see, guys, it is going up, but this is the length. So we're going to call it what? The height. But the height that we are talking about is the longest side of a rectangle, which represents, remember, the longest side is the length. Here we're just talking about the height to say it's perpendicular height. Remember, when it is to the 90 degrees. So the special name is the height, but we know it is the length of what? A rectangle, just the way that you are used to. So you know that the area of a rectangle, it's what? Length times width. So it's length times width. In our case, we have got what? Our length as the height and the breadth. So you're going to have breadth times height, or height times breadth, the same way that you want to present, because we are using H and what? H and B. So this is what we're going to use so that we have something that is uniform. So when we say the area of the strip, just like this one, where we have got the strip, which is for Y, you have a rectangle. I want you to use the same consideration. You are going to obtain your area this way. In actual sense, you were supposed to have, this is our representative strip. The representative strip is covering a certain distance. So this is the strip for Y. It is covering a certain distance here for the Y values. But it has a certain distance from where it is to this point, which in our case, this whole distance is what? Is our breadth. As we can see, this is our breadth, this one. So this is the breadth. You won't be talking about the whole of this line, which is the height, because we are talking about the strip is only like just a certain piece like this. So meaning to say, for a condition that we are working from the x-axis, as we are talking about this one, guys, we said from the x-axis, this is the horizontal. Let's use it as the x-axis, as you can see. So we saw that the distance here is y, this and that. I'm not talking about that. I'm just talking about the issue of the area of the strip. So if the strip is for y like this, it means the area of the strip was going to what? So for y, for the strip of y like this, we're going to see that area of the strip or area of strip is equal to, remember, it is supposed to be what? Length times what? Breadth. Length times, which is height times breadth. Our height is the what? The representatives that we have for what? For y. So that is y times the breadth. From here to here, this is how big from this point to this point. So that is your breadth. So this is the area of the strip for the strip of y. This is for the strip of y. If it was the strip of x, guys, we're going to have something else. The strip of x is going to be like what? All right, let's consider before we consider this one, the strip of x, before we talk about that. Remember here, I was talking about also the issue where the distance from where the distance is for y, the strip is for what? For y. We have taken that into consideration. All right, and we said this is our breadth. All right, so this is our breadth, and this is going to be what? Our height. We are talking about a rectangular lamina in this case. All right, it was from the x-axis. All right, from the x-axis. That is, our moment of inertia is about the x-axis. That is what it means. We're going to talk about the calculations later on. Do not worry. So in our case, let's consider another part. Let's say it is from the y-axis. All right, we're going to calculate the moment of inertia, whatever, but they're saying from the y-axis. So it means that is with respect to y. From the y-axis. All right, I'm just going to give you a basic view again with a rectangular lamina that we have there. Let us just say we've got something like this from the y-axis. It means the distance is the one that is affected. Yes, our moment of inertia is about that y-axis, but the distance, it will be from the y-axis. From, this is your y-axis, this one. So you are moving from there to this side. That is the distance that you'll be talking about. So your perpendicular distance will be for x. From the y-axis, the perpendicular distance is what? For x. But like I said, guys, once you have perpendicular distance for x, it means automatically the strip that you must have there is supposed to be what? For x. That is the condition. The strip that you're supposed to have automatically is supposed to be for x. So the strip for x is like this. Our representative strip automatically will be for what? For x. Perpendicular distance for x, the strip is for what? The strip is for x, meaning to say the limits are for x. That is our condition. So if it was a rectangular presentation that you are having there, maybe it's a rectangle that you are talking about, like I said, a rectangular lamina in our example. So we'll be having something like this. This will be our representative strip. The perpendicular distance from the y-axis is what? Is x. So these two must go hand in hand. As you can see, it's x. The strip is for what? The strip is for x. If your perpendicular distance is y here, like what we saw here, if our perpendicular distance is for y, like what we can see, we can also, it corresponds to the strip of what? The strip of y. So this is going to help you in drawing of these diagrams to know that these two exactly the same. These two exactly the same. All right. But in our case, guys, we want to talk about what? The area of the strip. Just like what we had here, we can see that, remember I said our rectangle, we are going to use the same format. The height, which is our length in this manner, and the breadth. So it means this was supposed to be in that manner that we are having. This is going to be our breadth, and this is going to be what? Our height. So I say that the area of the strip, so for the strip of X, our area was going to be what? Area of strip is going to be what? The strip is for X. So this is the distance here that we are talking about. So it's what? The distance that is for the strip that we have for what? For X times. What are we going to use now? The height. Remember, it is just like, guys, we are talking about this distance times what? The height. A rectangle is formed. Just like here. Are you saying we are forming a rectangle? This rectangle is formed by the height going up. It is the height. So it's the strip of X times the what? Times the height. So this is how you're going to have the area of the strip when it is for what? For X. For a rectangular lamina. A rectangle lamina. That is our case. So we'll talk about this, guys, into detail or into much consideration as we are going to be having questions. It will make sense when we are having typical questions to relate to. So this is it. As you now understand the issue of the strip, the area of the strip, the perpendicular distance, you now know this is your perpendicular distance X, this is your perpendicular distance Y there. Let's go back to our formula now to have our moment, which is our second moment of area. We are saying the second moment from our definition here is what? The quantity times the perpendicular of the distance. So we want to put that one now into a mathematical presentation. So it follows that as we are to calculate the second moment of area using this condition, second moment of area, second moment of what? Of area. So this also is measured in what? In units to the exponent of 4, like this one. These are the units. All right. So for us to calculate, we are saying here, the second moment of area is supposed to be the product of the physical quantity, the one that you are referring to. It's of what? It's of area. So it is supposed to be area times the perpendicular distance from the reference axis. So this is supposed to be the perpendicular distance from the reference axis, this one, from the reference axis. From the reference axis. Meaning to say, if the area was there, if the area is totally there and that reference is totally there, I can simply use this formula. But it won't be like that in our mathematical presentation. They want us to have or to use our integrals now. So it follows that in the integrals, the second moment of area, all right, sorry for that. The second moment of area is equal to the integral of r squared dA, like this, as an integral. All right. So as of our formula sheet, guys, I want us to talk about this because we have got these formulas from our formula sheet. So we're not going to talk about, we're not going to refer much, but I want us to be very careful. This is our presentation here, and we have to be careful now. This is a general view of the second moment of area, the integral of r squared dA. So what about this r squared? That is our perpendicular distance, this one, as we can see here. This one, the distance. So r there, we're talking of what? The distance, the perpendicular distance. The perpendicular distance from the reference axis. This is it. Then this dx, it is a presentation which is hiding the area there. Remember, it is supposed to be area times what? The product of that square of the distance. So this here is hiding, or it is meaning what? The area. But as an integral, it means the area of the strip. So this is area of what? Of strip. This is the area of strip. The area of strip, it is actually approximating to this, the area, change in area of strip. That is what I was talking about here. The strip for what? Here. Remember, I was talking about these areas. For a rectangular lamina, for the strip of y, it follows that the area of strip is going to be presented this way. Remember, I talked about this? The strip of x. So this is the one that you're talking about. The strip of y. But as we noted, guys, remember where the perpendicular distance is for y, the strip is for what? For y. Where the perpendicular distance is for x, the strip is for what? The strip is for x. So that alone is going to help you in the presentation to say, therefore, if we are to consider to say this is for x, as we consider as it is for x, to say now we are talking about x, how is it going to be like? It means it is going to be the integral of r squared, which is, or r is the perpendicular distance from the reference axis. So from x, it means that will be y squared times our dA is the area of the strip, meaning to say for a rectangular, let's talk about a rectangular, this one or of a rectangular one. I said when the perpendicular distance is for y like this, it means the strip that is used is for what? Is for y. So what does it mean? It means the area here that is going to be calculated, or the area of the strip that we are going to be talking about, will be for what? Will be for what? It will be with respect to what? It will be with respect to y. The area that we'll be talking about here. It will be the area for y. For y. This one. The strip of the area that you are going to have, it will be for y with respect to y. And we saw that for y, it is given as what? For y. This is where what we had our area of the strip. Remember, now it's just that I wrote these ones aside. That is the one here that we are having. Remember, change of strip times what? I mean, the change of this one times what? Times the breadth. So that is our area there. The strip for y times what? Times the breadth. So it is supposed to be the strip of what? Of y times the breadth. The strip is just approached like this, guys. What you are integrating with respect to, that is what you are talking about. The strip is for y. So you end up with this b, whatever that you'll be having, the limits being of a and b. But these a and b, the limits will be for y. This one. It means the limits here must be for y. So we'll talk about that. But that is just a basic presentation of what you have with those limits, this and that. So it will depend. Is it for X? Is it for Y? So guys, I'm not going to waste much of your time here, but this is the basic formula that I want you to have in mind. Once you've got this formula in mind, therefore we are done, because here we are simply saying that if it is the area that we are going to, I mean, the second moment of area, we are going to have the integral of this perpendicular distance from the reference. So that is the condition. So meaning say if it is for y, we are going to have the integral, the perpendicular distance So this one is now for y, so it will be x squared. All right. Then we are going to have the area of the strip, this one, which is the area of the strip, which is with respect to what? With respect to, it must be with respect to x. This one, remember these two, they are the same. Perpendicular distance and the strip, they go hand in hand, these two. So we must have x here, as I said before. So I think that can help. Yeah, that can help as you'll be answering your questions with this information. What else can we need to understand? What else can we need to understand? Guys, we're gonna talk about this in answering of the questions, because we also have a lot of things to consider as we shall be answering these questions. But let me see, because of time here, let me see what I can do. All right, I also want you to have these steps so that whenever we will be calculating, we shall actually follow the same thing together. So for finding the second, moment of area. So, all right. So to find the second moment of area, these are the steps that we are going to need. All right. So one, just make sure you draw a fully labeled sketch of whatever that you'll be given there. All right. So draw a fully labeled sketch. Okay. Must have a fully labeled sketch of the given information. Then you must determine from that sketch, you must determine the area of the strip. So determine area of strip. I was talking about this previously. So you must calculate that area of the strip. And also, guys, once you have the area of, for you to be able to calculate the area of the strip, you must have the distance. So let's start with the distance here. Then we'll put the area. Sorry for that. So you must be able to determine the distance first. The distance, you must be able to determine the distance of what? Of the strip. The distance of the strip from the reference. From the reference axis. Like what is that from the y-axis, from the x-axis? What are you going to use as the perpendicular distance of the strip? All right. Then you can now calculate your area of what? You must also determine the area of that strip. Area of strip must be determined. All right. This is what you need. And also, we must find the second moment of area of strip, not the second moment of area, but of the strip. Remember, I talk of here we calculated the area of what? The area of the strip. So we are going to determine, or we are going to find, or to calculate. Let us just use the same thing here, determine again, so that we do not, like, there are so many things that we are doing there. So we determine the second moment, of area of strip, of the strip. We are still on the strip. So just like the area of the strip, all right, when you are calculating the area of the strip, all right, this area of the strip will be like this, all right, that is the area of the strip, or this is the one that we said you can write no matter the way that you want in this presentation. So as long the strip is there, we must have this presentation D, or this delta. So we have the second moment of the strip, So it must be like this, the second, all right? That is the second moment of what? The second moment area of the strip. So as we have this, guys, definitely is going to be what? The perpendicular distance from that reference, that perpendicular distance from the reference squared times what? The area of the strip that we calculated here. That will be the condition. Remember, we calculated this here, area of the strip. This is what we need. Area of what? Of strip. So with this one is the perpendicular distance from where? From reference axis, the one that you call your reference axis, or the one that you are given as your reference axis. You're done. So as you can see, we determined the what? The second moment area of strip. This one, of strip. What we need is this one at the end, our second moment of area of the lamina. So what is going to be that one at the end? You simply have to integrate. So definitely, finally, you must determine the second moment of area. The second moment of what? Of area. Meaning to say the one that you are being given as it is, which is of what? Of the exact, of the whole thing of what? Of the lamina, which is about the reference axis. That is our condition, just like that. So is it for X? Now we are now finding the exact value there. Is it for X or is it for what? Is it for Y? By what? By integrating. So this here to have the exact value, that is where our integration plays a role. So that is by what? By summing. So to sum, that is to integrate using what? That is simply to integrate using what? Definite integrals. Remember your definite integrals where the limits are to be used now. The limits are to be used. So that is going to be the major case of this part. So like I said, in our case for the first part, we're going to work with a rectangular lamina. So with this one, I think we can be able to answer some typical questions for now as an introduction. Then make sure that, guys, you become part of the membership so that you do not miss any of the classes that we are going to be having there on our membership. So we want to use this information that we have gathered to attempt just one of these questions. Then we'll see as we move on. So here, there's a lot of things, but anyways, it's not that much. I want us to see this part of the strip so that I do not use much of your time here to refer back to and this and that. All right. So with this question that we are given, they are saying the sketch that we are seeing here shows a rectangular lamina. All right. Calculate the second moment of area about the what? About one, the x-axis. So this is going to be our question for now. Then we are going to have another one next class. So like I said, make sure, guys, you become part of membership so that you do not even miss any of the other classes that we shall be having from there. All right, so this is it. They're saying we are supposed to have this from the x-axis, the first one. So I want us to consider this diagram as it is. All right, we are given this. Let us see. So from the x-axis, meaning to say we're going to calculate what? The moment of area with respect to x, which is, this is the presentation that we are supposed to have. All right, no problem. According to the sketch that we are given there, we are given a rectangular lamina like this, which is in this manner. All right, so this is what we're going to have. We have the height and the breadth. All right, even if they used any other way, they were going to. So we must use the same format here, meaning to say, according to our rectangle, our rectangular lamina, we said in our case, so that we use something that is uniform. This will be our breadth, and this will be our height, which is the length, all right? So that we just have that perpendicular concept. So that is what we're going to have here, breadth, and this is our height, which is not a problem. So we are going to consider now to say, what is it? Which axis are we referring from? Which axis are we referring from? From the x-axis. So if we say from here, guys, here's the moment, about the x-axis, about, meaning our moment, our second moment of area is taken about this x-axis, about the x-axis, but the perpendicular distance is from that. So we must move from the x-axis, from, meaning to say it was going to be like this. If you know about the perpendicular distance, guys, you are done. Because you know, okay, I was supposed to have what? A perpendicular distance going up for the y, because this is what? From the x, it's going up. We are talking about the y values. Vertically, it's y values. So once you know that I have a perpendicular distance for y, it corresponds with what? Its strip. Remember, I said the perpendicular for y, the strip is for what? For y. These two, they go hand in hand. So automatically, you know that you are going to have the strip for what? For y. Just like that. So we are using the representative strip is for y. Just like that. So guys, what are we trying to say here? This idea, it simply means when we say the strip is for y, it means the limits are for y. The limits here are the y values. So what represents the y values? It is the height, perpendicular, this one, vertical, I mean. We're talking about what? Y there. So the limits for y. So it's here. What is the value corresponding? That's from 0 up to what? Up to h. The height. If it is 30 centimeters, it means 30 centimeters going up. From here to here, it means this will be our h at the end. So just like h here. The whole of this is our height. This is the one that we are going to use. The whole of this h. So it means as our limit in our case, if we are talking about from here, from 0 here in the x-axis, we are at what? At 0. So that's from 0 to what? From 0 to h at the end where h is. These are going to be our limits. So with this, guys, with this information is enough. With this, we can even attempt our question. Try to attempt our question. Remember, I said on these steps, how are we going to determine? All right, let me see where I wrote those steps. I think it's here. All right, finding the second moment of area. We have drawn our diagram. What do we need to do? What we need to do here is to determine the distance of which we have already that. So we need the area of strip. So in our case, we have already this distance. So we know our perpendicular distance is y there. So we said we are going to need the area of the strip. So that is our condition, just like that, area of strip. Area of what? Of strip. With respect to what? The area of our strip is with, this is just like dA, like this, area of the strip. This is our strip here. With respect to what? So as we have our condition, remember, if you have a rectangle like this, how are you going to calculate the area? Height times the length times breadth, which is our length is what is the height. So it's height times breadth, or breadth times what? Breadth times height, whatever way that you want. That was supposed to be the area of the rectangle, the breadth times the height. So when you talk of the area of the strip, what is representing our breadth? It is still the same breadth as it is times what? This height. Our height is the part of the strip. So that is the strip. What? Why we talked about this, guys, in our previous case. If you've forgotten, remember, I was talking about these ones here. So as you can see, that's one and the same thing. So we have that one. This is the presentation of the area of the strip. All right. Then what else do we need? The second moment from there. We are going to need the second moment of area of strip, This is of the strip that you're going to determine. So the second moment, let me just write. Second moment of area of what? Of the strip. So in our case, we are talking about what? With respect to x, as we are given about the x-axis. So it was supposed to be what? This is the one that we are saying the distance, the perpendicular distance from the reference axis squared times what? The area of the strip. So our distance, that is the one, the perpendicular, y there. So it's going to be y squared times what? The area of the strip, this one, we already have it. The area of the strip, we calculated that. So in what is that area of the strip? Here, we already have this. So we're just going to take that part as it is, which is our area of the strip, which is the breadth times what? The strip, y. So this is how it was supposed to be like. From there, guys, integrate this. That is the condition. Determine what the second. We're now finding the exact second moment of area of Lamina about that reference axis, or about what you're given. In our case, we're talking about what? About x. We can calculate that. So therefore, using our integral, the second moment of area about the x-axis is going to be the integral of this whole part that we are seeing. So that's y squared times b times, remember, this here, the strip, simply means with respect to what? With respect to y. And I said, with respect to y, thus the limits here are for the y. With respect to x, for x. This one, with respect to y, so our limits are from what? From 0 to h, vertically with respect to y. So if it is for x, from 0 to what? B, this one, the breadth from 0 to b. For y, from 0 to h. So these will be our limits from 0 to h. So guys, as we can see, this is the integral that has to be done with respect to y. So b is just a constant, our breadth. So our answer is going to be in terms of b. All right. And what the h, because you're not given the exact value. If we are given, then we can substitute those values. Like we're given from 0 to 10, whatever that you'll be given, then your answer can be in terms of b. But here our answer is going to be in terms of b and what? And h, the limits. So b is a constant, take it out of the integral so that we can integrate what is remaining with respect to y. So that is our case from 0 to h. So let's integrate, guys, as we know our integral with respect to y. So simply have to add 1. So that was going to be b times y to the exponent of 3 over 3 with our limits from 0 to what? To h. So just like that, we substitute our limits, upper limit minus the lower limit in place of what? Of y. Our upper limit is h, so that's h to the exponent of 3, whatever value that you're given there, over 3 minus 0 to the exponent of 3 over what? Over 3. So as we can see, these guys were simply going to give us what? A 0 there. So at the end, we're going to have b times, simplify this, it was going to give us h to the exponent of 3 over 3, which is same as bh to the exponent of 3 over 3. This is the same as over 1. So you can simply multiply the numerators together, the denominators together. That is our condition. Remember the units for the second moment of area. We said this is units to the exponent of what? Of 4. In our case, we cannot say these are centimeters, these are meters. We're just going to use units as it is. But sometimes you might be given the proper units. So that is how you calculate your second moment of area. So this one was with respect to the what? Was with respect to the x-axis. Was with respect to the x-axis, you can see. That is how we simply have this one. So this one is a conditional type of a question. You work with the condition. As we can see, the second one is for the y-axis. All right, I was thinking that you're going to have this on a different class, but let us just have it at once here so that we finish. So let us see how it was going to be like when it is for the y-axis, or when you are referring about the y-axis, what was going to happen. So this is how we calculate this, guys. We just have to understand all those like this, the basic steps. So here we're dealing with a rectangular lamina. All right, so if you're to consider about the y-axis on question number 2, so this time we're going to calculate about the y-axis. So as of our diagram, we just going to redraw this so that we present those strips, whatever that we have there, as we have about what? About the y-axis. So we're just going to have something like this, our rectangle, the way that it was in this manner. All right, so this was our rectangle, guys, and we have the breadth and the height in this case. So as we are saying about the y-axis, it means our representative strip. How is it going to be like? All right, let's talk about the perpendicular distance first. From the y-axis about, so it's from the y-axis, from going this side. That was going to be our perpendicular distance, meaning to say it represents the x values from the y-axis like this, perpendicular like this, horizontally. Remember, these are the values for x. So if the perpendicular distance is for x, definitely, what does it mean? The strip will be for what? For x. Like I said, the representative strip goes hand in hand with what? With your perpendicular distance, this one. So that is going to be our condition for a rectangular lamina that we are having here. It means our strip, this one, was going to be for what? For x. Perpendicular distance is for x, the strip is for x. Once you have this, guys, you won't even go wrong. So once you know I am using the strip for x, what does it mean? It means the limits are for x. It affects the limits here. Remember, I say this for x. So in the x-axis, our limits are starting from where? From this point, our rectangle, from 0 to where it ends, which is the breadth, the whole of the breadth here from 0 to B. Take note, H, guys, when you say H is not a point to say this is H. No, H is the line, this one, the whole of this line. So it ends here to say the whole of this line. Our breadth, the whole of this length, the whole of this line is our breadth. So our limits will be from 0 to what? From 0 to B. That will be our condition from 0 to B, because we're talking about the x values. Understanding this, guys, is enough for you to answer this question. Just this, you are done. All right, let's answer our question. As we can see, we said this, we have already drawn this one, determine the distance. So let us quickly go to the what? The area of the strip. So what is our area of the strip in this case? So area of strip. All right, in our case, what is going to be area? So as we have area, breadth times what? The height. So our breadth is the one that we are having, this, which is our strip. So that is the, all right, so that is for area, this one. So is the strip for what? For x that we are seeing there times what? The height times the height. So that is how it was supposed to be like. And we also determine the moment of area, all right? The second moment of area for the strip again. All right, so guys, I'm not gonna write this one in words. I'm just gonna have this one. All right, remember you're supposed to determine what the second moment area of the strip. So this is the one that you're gonna determine. The second moment of area of the strip is the strip for what? Remember, for y there, we are referring about the y-axis. And this is the one that I said, it is the perpendicular distance, the square of it, this one, the perpendicular distance squared times what? The area of the strip. Our area of the strip, we already have this one times our area of what? Of the strip like this. So this was going to be our presentation. The area of the strip as it is, this one. This is the part. This is our area of what? Of the strip as it is. So we are going to integrate now. Finally, we integrate to determine what the whole integral at the end. So therefore, our second moment of area, the exact value, was supposed to be the integral of this part that we are seeing. So that is x squared. H is a constant. We can even take it outside. So this simply means with respect to what? With respect to x, all right? Our limits are for x with respect to x. Like I said, the limits are for x from 0 to what? From 0 to b, which is the whole of the breadth that we are talking about. So that's from 0 to b, just like that. So you can integrate this, substitute your limits, you're done. So what is going to be our second moment of area about the y? That was going to be h. We integrate with respect to x. Remember, we're going to add 1 here. So that's x to the exponent of 3 over 3. And our limits being from 0 to b. So that is it, just like that. So we're going to substitute upper limit minus the lower limit, just like the previous case. So b in place of x, that's b to the exponent of 3 over 3 minus the lower limit in place of x, 0 to the exponent of 3 over 3. So as we can see, this whole part was going to give us a 0. So we were simply going to have these two at the end, the product of h and this one. So that's hb to the exponent of 3 over what? Over 3. That is our second moment of area about the y-axis, just like that. So guys, do revise as many questions as you can because they will depend, these questions. You are going to notice different types of questions on the condition that you're given. So you must work with the condition that you're given. So like I said, do not forget, guys, make sure that you become part of the membership so that you won't miss any of the other classes that we are going to be having as we are revising our mathematics N5, preparing for the exams which are ahead of time.